In this movie, we will learn how to make what is called a sign chart to help to describe how a function is behaving. In this case, we will look at the function minus 5x cubed plus 30x squared plus 5x minus 150. To start analyzing this, the first thing you should do is completely factor the expression. Once we have completely factored the expression, we need to start to use the factored expression to help describe parts of the function. The first thing that we will look at is where is this function 0. Take a look at this expression and determine where this function will be 0 before you continue. Of course, this function is 0 when any of the brackets are 0, so that means x equals 5, x equals 3, or x equals negative 2. To do this analysis, we have to break up this function into regions. We're going to use the zeros to help define those regions. Now we construct the chart. We start by putting our intervals or regions along the top and our factors along the side. Let's talk about the regions for a second. The lowest 0 is negative 2, which means one of our regions is going to be anything less than negative 2. The next region will start at negative 2 and end at the next highest 0, so between negative 2 and 3. The region after that will start at 3 and go to the next highest 0, which is 5, so between 3 and 5, and the last region will be anything greater than the highest 0, so x is greater than 5. Each row represents one of the factors, and we must include the factor of negative 5, and the bottom row is going to tell us about the actual function itself. Now you'll notice that this is called a sign chart, and the reason it's called a sign chart is we are going to fill in the sign of each of these regions for the individual factors. So this table will be filled with positive and negative signs based on our calculations. And the easiest place to start is at the factor negative 5, because no matter where we are in any of these regions, this will always be a negative number. To continue, we'll concentrate on the rest of this column for the region where x is less than negative 2. Before you continue, try to figure out the sign of each of these factors for values that are less than negative 2. You should have gotten all negatives. If you're not sure how this happens, let's consider any value that's less than negative 2. For example, negative 3. If we look at x minus 5 and put negative 3 in for x, you get negative 8, a negative value. If you put negative 3 in for x for the next factor, you get negative 3 minus 3, or negative 6, still a negative value. And if you put in negative 3 for the last factor, you get negative 3 plus 2, which is negative 1, and still a negative value. So what this means is that each of these four factors is negative when x is less than negative 2. And if you have four factors that are multiplied together that are all negative, that means their product, no matter what the value is going to be positive. Try the same analysis for the next region. Choose a value between negative 2 and positive 3 for x, and see where each of the factors are, positive or negative. Try this before you click to continue. In this range, an appropriate x value to choose would be 0, nice and easy to calculate with. And when we put 0 into x minus 5, we get negative 5, which is negative. When we put 0 into x minus 3, we get negative 3, which is negative. And when we put 0 into x plus 2, we get positive 2, which is positive. So now if you have four factors, 3 of which are negative and 1 that is positive, when you find the product of those four factors, regardless of what the values are, you're going to get a negative answer. And again, before you click to continue, try this for the next column of elements for values between 3 and 5. So now we choose an x value between 3 and 5. The easiest one to choose would be 4. And if we put 4 in for x, 4 minus 5 is negative 1, a negative value. And it's important to point out here that we could have chosen a more difficult value to use, like 3.2, And when we put 3.2 in, we get negative 1.8 as the answer. It doesn't matter what x value you choose. Any x value in this range between 3 and 5 will end up with, in this case, a negative value. And so when we put 4 in, x minus 3, we get positive 1. And when we put 4 in for x plus 2, we get positive 6. So again, we take our 4 factors, this time 2 negative and 2 positive, and when we multiply those values together, we're going to get a positive answer. Finish the last column off before you click to continue. So choosing any value bigger than 5 now, when we plug into our factors, let's say we choose 10. 10 minus 5 is 5, positive. 10 minus 3 is 7, also positive. And 10 plus 2 is 12, also positive. And so in our last interval, we have 4 factors, 3 of which are positive, 1 is negative, so the product of those 4 factors will be negative. And so the function f at x starts out being positive. It becomes negative at x equals negative 2. It becomes positive again at x equals 3. And it becomes negative again at x equals 5. And so now with this analysis, we have information about where the function is positive and negative. Now we could do the same analysis if this was a derivative, and this would tell us where the function is increasing and decreasing instead. Or if it was the second derivative, it would tell us where it was concave up and concave down.